All right, so today we're going to do number 24 on quiz 1. But before we do that, let me explain a couple things, some general ideas that might be helpful, not just for this one, but in general. Here's first general idea for today. Anytime you have log or ln, by the way, in higher mathematics, ln and log are used interchangeably. Anytime you have ln of 1 plus anything, and I mean anything, it could be cat, right? Anything here. That will always behave just like cat so long as cat is getting small. In other words, the limit as cat goes to 0 for ln of 1 plus cat over cat is equal to 1. These are saying the same thing. The fact that the fraction is equal to 1 means that the numerator is roughly equal to the denominator. So this is roughly that for small cats, as long as this thing's getting small. What that would mean, that means, and I'll let you try to think about how to prove that, or I could prove it for you, but that would cost extra money. And that would mean, for example, that if I take the ln of 1 plus 1 over x all over 1 over x, and we're taking x is going towards infinity, that means that this piece is getting small and small. So it looks exactly like this. ln of 1 plus a cat over a cat, and the cat is getting small. That goes to 1. So this limit will be equal to 1. And particularly, it also means that, for example, the limit of ln of 1 plus negative 9 over x all over negative 9 over x would also be equal to 1 as x goes towards infinity. That's one of the pieces here that we have to contend with in just a second. So it doesn't look exactly like this, like a 1 plus 9 over x all over that, but it does look like the numerator of that. Okay, that's a general idea. Another general idea is that the sine of x all over x as x goes to 0 goes to 1. That means that, roughly speaking, sine of x is approximately the same thing as x for small x's. X is going to 0. Also, it means that anytime you have sine of whatever, cat, you can think about it as approximately equal to cat for small cats. Okay, in particular, if I have cotangent of 1 over x, that's the same thing as a cosine of 1 over x all over a sine of 1 over x. And I can multiply top and bottom by 1 over x, and then I have some sort of syntax like this one, and I'll know that goes to 1 as x gets large, because as x gets large, this quotient gets small. All right, those are some general ideas. Now let's see how they play out here. I'm going to use those ideas and a little creativity to rewrite this as log 1 plus negative 9 over x all over negative 9 over x. Now you see that part right there is illegal. I can't just put on there whatever I like. However, I can do it if I do balance it out with the 9 over x on the top, essentially multiplying by 1, which would be allowed. Here I break it up as a cosine of that over a sine of that. Actually, I'm going to go with blue here, because the red's going to be the things that I do to both top and bottom. So, and then I'm going to do something clever again, just like on the other one. I really would like to have a 1 over x on the top. 1 over x all over 1 over x, so that it looks kind of like this. Sine of cat over cat. Sine of cat over cat as cat goes to 0. Of course, in our case, our cat will be 1 over x, and x will be going towards infinity, so that 1 over x goes to 0. All right, and then I try to clean it up a little bit. I leave the things that I know how to handle. For example, I know how to handle log of 1 plus negative 9 over x all over negative 9 over x. And I know how to handle 1 over x all over sine of 1 over x. that would look exactly like this. Sine of cat all over cat is going to go to 1 for small cats. But, you know, the inverse would be the same thing. Cat over sine of cat. The reciprocal of 1 is 1. So that will be approximately 1 as well for small cats. And so that's exactly what I have here. What's left over, let me highlight the things I've done here. I have this piece here. I have that piece there. In addition to that, I have this piece here and that piece there. I have those things. The ones that are missing are, of course, the ones that are not highlighted, negative 9 over x all over 1 over x. So this expression is equal to that expression. However, when I take the limit as x goes towards infinity, I know what's going to happen here. This is going to go to 1 and this is going to go to 1 based on the previous discussions. So the only thing I'm left with is just this part right here where the 1 over x I can cancel, and I can easily see that that's equal to negative 9. See that? Negative 9 times 1 if you want to be technical about it. But of course that's equal to negative 9. And that, my friends, is a beautiful use of this concept right here and this concept right here. Apply to that in an elegant way. All right, don't forget to hit the subscribe button. See you guys next time.